Apply, this is used to evaluate a function, often an anonymous one, over the margins of an array. So it is most often used to apply a function to the rows or columns of a matrix. So it can be used with general arrays. Example, you can take the average of an array of matrices. It is not really faster than writing a loop, but it works in one line. That's a simplicity of apply. So what does str of apply give you? It is a function which takes x, the margin, and a function. So basically the element, the list where the function is being applied, and you have an extra parameter called margin. So what is that? So x is an array, and margin, it is an integer vector indicating which margins should be retained. So function is the function to be applied, and ellipsis as always for the other arguments to be passed to the function. Now, so here you have a matrix of random normal variables 200, number of rows equal to 20, and number of columns equal to 10. Now when you apply the function apply, so you have x, 2, and mean. Now you are specifying that the margin is 2. So basically you'll find, you know only 10 variables, 10 for each of the 20 columns. So that's the reason apply is giving this. And when I use apply of x comma 1 comma sum, now I'm taking margins to be read as 1. That's the reason I'm getting 20 outputs for this, for each of the rows. So this is where apply is much more useful. You can try to retain the specific margins that you want from the data. So when you want to perform column sums and row sums and means in a matrix, you can always use apply. For example, for sums and means of matrix dimensions, we have some shortcuts. Row sums equal to apply of x comma 1 comma sum, so it will give you first row and it applies the function sum. And row means same way, the function is mean instead of sum. And when you want the column sums, you can use apply of x comma 2 comma sum, which means the column will be considered. So call means of apply of x comma 2 comma mean. So the shortcut functions are much faster, but you won't notice unless you are using a large matrix. So other ways to apply, so if you have quantiles of the rows of the matrix you want to get, so quantiles are normally 25, 50, and 75, and complete. So this is how the quantiles are defined: 1 to 25, 25 to 50, 50 to 75, 75 to 100. So when you apply to the range of the quantiles, so apply x comma 1 comma quantile comma probs of equal to c of 0.25 comma 0.75. When you apply this, you will get the following result. So you'll get for result for each and every quantile: 1 2 3 4 5 6 7 8 9 10 11, each of the quantile you will get the result. So this is how apply can be useful to you. So the average matrix in an array, so A is an array where random normal of 2 into 2 into 10 comma c of 2 comma 2 comma 10. When you apply, you want to get c of 1 comma 2, and you want to get the mean for those, you can use this and you will get the row means. And same way, if you want to get row means of a comma dims of 2, you'll get the same values, exact same values as this, which means you are the apply of c comma 1 comma 2, which means the first row. It is a basic, the same function is followed by row means and apply. So that is the way apply is used. Now we'll see the part 2 of loop functions, where in the part 1 we saw about sapply, lapply, and apply. Now in the loop functions part 2 we'll see some more the apply functions. So here we have a function called tapply. So what does tapply basically do? So tapply is used to apply a function over subsets of a vector. So basically we saw about lapply, where the apply function applies for each element of the list, and sapply function where the result set is simplified, and the apply function where you apply the functions over the margins of the data. But what does tapply do is, like, let's say you have 10 elements and I want to specifically apply a function to 10 or 3 to 5 elements. Then I can use this tapply function, which will extract a subset from the existing list, and then the function will be applied over it. So the reason why it is called tapply is unknown to any of us. And when we see the function structure of tapply, so using the function str of tapply, you'll have x index function equal to null and simplify equal to true. So what is this actually? The x is the vector that is being passed on to. Index is a factor or a list of factors, or else they are caused to factors. And fun is the function to be applied, and ellipsis as always contains the arguments that should be passed to fun. Simplify equal to true or false. Do you want to simplify the result or do you don't want to? So tapply basically function, like functions like the sapply here. So when you want to take specific group means, you can always go for this tapply function. So let's say you have a element called x, where you have the random normal distribution of 10, or uniform distribution of 10, random normal distribution of 10 comma 1, where the mean is 1 and there are 10 variables. So when I apply a function, when I create a subset wherein the f is a subset, and I'm exacting GL of 3 comma 10. So now when I use f, you'll have the values. This is not a subset actually, this is having values. I'm trying to repeat 3 10 times, so till 3 10 times. So 1 you'll have 10 times, 2 you'll have 10 times, 3 you'll have 10 times. So this is the function on f, this is the level for, and you have this factor, you'll have 3 levels, 1 2 1 3. So now if I want to apply the tapply function with x comma this factor and mean, so you'll have 3 levels and you'll get correspondingly 3 levels of mean. So you've correspondingly applied this factor over x, function over x, and you created, you found out the mean. If I do tapply without simplification, what does happen? So I'm taking the same example here. So I want to take group means without simplification. So tapply of x comma f mean comma simplicity equal to false. When I set this, I'll get the without simplification result, wherein I'll get the list again as the result set. So finding group ranges. So same way of applying mean, you can apply range, wherein it will give you the range of each of the levels of the data. For example, when I use the tapply of x comma f comma range, I'll get the range of values in the function f. So initially it was random normal to 10, random uniform of 10, random uniform of 10 comma 1. You'll get the range for each of the elements in that. So this is where tapply correspondingly you create subsets, 3 different subsets, and try to find the range or mean or any kind of function that you want to calculate. So moving on, as I told you earlier, I will tell you about a specific function called split. What the split does, split, it takes a vector or other objects, and it splits it into groups determined by a factor or a list of factors. So doing a str of split, it will structure of split, it will tell you it's a function which contains variables, parameters x, f drop equal to false. So x is the factor vector or the list or the data frame that is being passed on, and f is the factor or corresponds to 1 or a list of factors. Now drop, it indicates whether empty factors levels it should be dropped or should be considered.